Good morning, everybody. Thanks for coming to this session. I hope you are not going to catch a cold because I think this is super cold into that room. I might be wrong, but this is my current feeling as being European. The air conditioning is just crazy in the convention center today. So my name is Jean-Marie Verdun. I do work within the Advanced Engineering Group at HPE with Arun. We are here today to discuss a little bit about open source firmware strategy at HPE and what do we do to bring it to our customers, which are enterprise-based customers and cloud service providers. You might be well aware that we have announced an Ampere-based systems a few months ago, and this machine is going to hit the market within a month. That will be the first machine that HPE ever shipped with OpenBMC capability and potentially Linux boot capabilities. And this system is going to be fully supported by HPE. So it means that there won't be any specific warranty modifications or any special clauses within the contract and the relationship between us and the customers and the end users. So this has created a lot of hurdle and internal discussion with our support teams because, as you might be familiar, firmware is deeply involved regarding our support capability. And to address this concern, we created a tool for providing testing and validation at scale. So we call that tool open source firmware continuous integration platforms, OSF-CI. This is an ongoing development from my team and Arun's team, which was designed initially to address the challenges we all faced during the COVID pandemic on how to develop remotely open source firmware and proprietary firmware on live hardware. But right now we are expanding the tool to expose it to our customers as being a test bed and a validation bed for their own firmware images and source code modification. One of the biggest challenges when dealing with OpenBMC, for example, is that anybody can get access to the fan tables. And if you messed up with that, so you might be lowering the lifetime expectancy from your systems, which is not really good. It's not the interest of the end user. It's not the interest of the supplier too. And we needed to find a way just to provide a burn test and validation. So we are coupling the tool with engineering prototypes and systems, which will give us enough data to give a green light or red flag, depending on the outcome of the test that will be running on the systems. But Arun is there to run a live demo of the tool. So as this is a live demo, so the tool is available on the internet. The source code is available on the Open Compute Project website, GitHub, sorry, not the website. You can contribute to it. If you want to deploy it for your own purpose, we are here to help you. Even if it's not on HPE platform, we don't care. So we are more caring about having good quality open source firmware at scale. And we believe that it needs to go through deep testing of the code, especially on the BMC side, which is a very complicated software stack. Go ahead, Arun.
So I think the most exciting part about this system is the fact that it's running on live hardware. So there's no emulators involved. It's actually deploying on actual live hardware. So before I get into the demo, I just wanted to give you the rough structure of what we'll be walking through. So assuming that you have an account on the tool, which is open to all, and you can get an account as a member of the public, you have a time session that you can grab on one of the server boards for your purpose, which is right now set at about an hour. So you're actually locking in an actual server piece for your testing and development. And you can do a custom build of OpenBMC. Same goes for your BIOS. In our case, we've done a lot with Linux boot. And then you can load that a custom build that just was done and make sure that you are able to see how it would be if we were actually live loading it on the BIOS. And then after that, you can literally turn the power on the machine that you've just built with this new firmware, and it's actually powering it on. The facility is in an actual colo in Texas, and it's all running on live gear. And you will notice that on the side, now you have the live OpenBMC prompt, and you've got lots of nice features, including access to the BMC web. We are working closely with the OCP community and the test and specification framework, so you can actually see a first integration appear with Facebook's contest. And if you're interested in that, you can attend my colleague's talk later this day, where we will be discussing a bit more on that strategy and so on and so forth. And then you can actually run a contest test right from all of this stuff. And then, of course, you've got access to your BMC web, which is the standard bit right from the tool itself. And let's assume that you're a developer and you don't want to have all the webby stuff. Then you can literally use our API interface to write your own tools. This is an example where we have done so, and we've done some scripts. You can build your own scripts. I'll be getting into a bit more when we do the demo. Now, I think it's a good time to run through the demo. So this is the live tool. And in the interest of time, we obviously didn't want to do the build process in its entirety while we are on the stage. But as you can see, we did a custom build on a certain branch that we're working on pretty actively. It completed the build, so you have a full compilation service for both Linux boot and OpenBMC. And Jean-Marie can maybe explain a bit more about some of the architectural decisions that he took while he first framed the tool.
That's easy. So roughly what we have created is a Docker image, so a container image, to recompile automatically OpenBMC and Linux boot and inject Linux boot directly within a ROM from HPE. So when you open up a session on the CI, you select the hardware target you want to test. So we got plenty of different servers at HPE. So you will be getting access to ARM 300, which is the Ampere-based systems, or Intel or AMD-based machines. So the goal there is really that as an end user, you recompile your stuff, you generate the image directly from the tool, and you load it on the servers.
Excellent.
So now we can load the...
Yeah, so hopefully this works. You can load the firmware that you just built.
You can go to the next one too. Load them in parallel.
Yeah. So as you can see, it's live loading both the server, both the images that was just built. And for the firmware developers in the room, you know that this step itself would have probably saved you half an hour at the minimum. If
Just
you were to
go
do
down.
It. Yep.
So when the image is fully loaded on the emulator, we can turn on the power. And this is just going to bring up the new firmware image to a live systems.
All right.
So what we are intending to do within the next generation while OpenBMC is booting is putting our servers within a thermal chambers. And when you will be running thermal stress of systems as being an end users, so we will be getting direct feedback from the various probes we will be putting into the servers. So we're setting up our first machines next week in Houston. And we want to give the opportunity really to test the system under heavy stress or under a specific workload. That is also why you can preload the operating systems on the machines. So assuming that your updated firmware is booting properly the systems, so you can deploy on the target system either Ubuntu or Red Hat or any kind of Linux flavors that you are willing to use in production, and setting up that image to your own purpose. And that's really critical to test the firmware from an end-to-end solutions, from the compilation up to the burn test. And if the burn test goes well, so we really can provide this kind of feedbacks. The other thing is HPE is a global company, so we got customers everywhere around the world. And our open source firmware team is a small team, which is mainly located in the US. And we needed to find a way to replicate issues when customers will be on different time zones or different geos. So like that, we have a common development platform. And after the issue replication, we can address it together with the end users. So the end users could be an HPE customers, or if you are not an HPE customers, you can use the tool for free and discover how open firmware behaves on HPE platforms. If you want to use the same kind of tools for your own infrastructures, which might be based on different vendors, so it's quite easy to add a new target, I believe, and you will be able to integrate your own systems.
So another neat feature that we've just introduced is that you can actually get the cooker logs as well. So in case you wanted to have a deep dive on what just happened, we're enabling it both for the BIOS as well. This will be available on the public CI as well. As you can see, it's dropped me into a OpenBMC shell.
And you get a live session, so you are really connecting to systems which is based in Houston. And you can run any kind of command and take care of managing the systems and validating that your image has been properly set up as you were expecting.
And let's see that thing that I was talking about, the API, right? You could run the whole thing, what I just showed you, on the web via your own scripts. And the way to do that is by either writing your own based on the examples that we have provided, or you can retrofit the examples. So as you can see, I got a session. I built a custom branch, just what we did on the web. I can get the image, I can get the logs for it, and I can get the build status, and then I can release my session as well. And as an example, if you look at the start session, it is a simple script that is literally using the endpoints that we have defined on the web end. So as long as you've got an auth token, you can build pretty much in whatever languages you like. So that is the API side of the fence. So you don't need the web interface. Now, if we go back, you can see some really interesting things, one of which is the fact that now you do have the OpenBMC web management. So you can literally go into that and just log in to the system that you just built with your custom firmware. Very cool.
I think we're going to run out of time.
Yeah, and the last feature that I wanted to say is the integration that we're working with on Facebook and OCP for the test frameworks. So you can run your contest tests from here as well. Again, all of this is available via the API.
I think what is critical is when we started to thought about enabling open source firmware on HP platform is how do we scale and how do we ensure that what is going to be executed on the platform for many different customers with many different approaches to the technical challenges that firmware needs to address. We could deliver tools and testing environment which will bring a good point of view and a good understanding on how the modification that an end user is willing to provide will be efficient and work. And we are currently believing that there is no other way than going through automation and building a database of tests. And that's really critical. That's also why we are getting involved more and more within the test work group that is currently set up within the OCP organization. So testing what we do is really critical, especially when dealing with software. And we are currently using this tool at scale inside HPE before opening up OpenBMC to all of our customers, just to be sure that it's good enough for our own purpose and that our end users will be able to use it properly.
So a brief note about the architecture. It's fully modular, configurable, and written in Go. As you saw from the API demo, we do have API endpoints, so you can use this tooling without engaging the web front end. We do have an excellent logging and analytics backend for the tool itself, so if you're interested in that. And of course, it's fully open source under the MIT license, and now is fully owned under the OCP GitHub. So you can get all the details on that right here. All the information is right here that you would need. We'd love for people to engage with this tool and help us build it out further. As a call to action, I think Jean-Marie already described the bigger picture. And basically, we would love to have specially provisioned instances for customers, the public, and OCP, which we're working on. So we'd encourage you to contribute to the code base and to the lab and all of the cool ideas that I'm sure that the community can come up with. Thank you for your time.
Thank you.